We are going to see wind energy in wind turbine site selection. So we are installing the wind power station in the sense how the site has to be selected. The selection of wind farm site is very complex and it is also time consuming. It also involves multiple discipline work on the parallel path, like financially we have to strong, government permission has to be taken, we have to see the meteorological studies while we are installing that particular land, and land use restrictions also we have to see, and we have to design the entire system before going for the approval. And also before going for the construction we have to do everything, we have to do everything. If it is ready, then we can go with this installation or the construction of the power station. So construction expertise will be involved and consulted to achieve the maximum use of approved site. There are three principles of source of construction expertise the participating in the wind farm projects. They are, first one is a design team, developer team, and contractor. These three are the principal source of constructions. Design team is responsible for the conceptual and eventual site design. They have to go for the site design. Developer team or otherwise construction manager team, they have to manage the project, construction manager of the project. And the wind turbine generator contractor, they have to go for the development of the turbine. So wind is the energy source that drives the wind turbine. So windmill needs to be placed on a high tower located in the wind area. It's not just like any wind will do the rotation of the blade. Wind turbine needs air that moves uniformly in the same direction. No turbulence is used to rotate, or no eddies or swells does not make good resource for the wind turbine. Rotor cannot extract the energy from the turbulent winds and constantly changing the wind direction due to the turbulence or excessive wear and tear, which will makes the blade to be damaged or turbine to be damaged or interior parts will be getting failed. That means the turbine must be placed in high enough to catch the winds above the turbulent air. Turbulent air is the low pressure air. Above the turbulent air we have to keep that turbines while we are going for the location. So the tower price is goes up quickly with the height. Number of how much height we are keeping, that is very important. Minimum is 20-meter height the tower, and above that we have to keep. Or sometimes you have to see about the obstructions, what kind of obstacles are there for the wind. It may be the large tall buildings which will obstruct the wind, or the trees nearby 200 meters or 300 meters. The trees will affect the wind which is blows onto the blade. So we have to think while we are installing this turbines, because any turbines may be 20 years maximum. After that we are removing that one, we are dismantling that. So in the 20 years of time the wind has to be blown onto the tower continuously whenever the wind is blowing. That should not be affected by the or obstructed by the trees. So trees normally it can blow, it can grow up to 20 meters, in the sense that we have to keep more away from the 20 meters, the blade has to be fixed. So that is nothing but the turbine site selection methodology, how we are selecting the things for the implementation of wind energy extraction or wind power station. So what are the things to be considered in the sense? Turbine height we have to consider. Site selection consideration, in that the hill effect, roughness of the amount or the friction of the earth surface, tunnel effect, turbulence, variation in the wind speed, wake, wind obstacles, wind shears, power output variation with the steady wind speed, Parts of the wind turbine, these are all the things to be considered while you are going for the wind turbine site selections. First we are going to the turbine height. This is nothing but a turbine. This is tower, it is a blade, and over that is kept is nothing but turbine. Turbine is nothing but turbo generator. So wind turbine should be sited well above the trees. The tree level is 150 meters, in the sense above the level only we have to keep. Like that only we have to keep it. If we keep down, in the sense, then it is a difficult. The distance should be 150 meters minimum. Then only it is good. It is not harmful to the any wild animals. 150 to 250 meters is very good, appreciable. And height should be like, we have to see that the plant is growing to the tree, in the sense, the plant is converted into tree, in the sense how much height the maximum one plant will come. It is maximum height. We are keeping the 20 meters, minimum, maximum 30 meters. And this is the thing should be more than 10 meters from this power station. Like that we have to keep it. So wind turbine should be sited well above the trees, buildings and other kind of obstacles. When the wind flows over the obstacle like building or a tree, the wind is getting slowed down and the turbulent is created. Wind is getting slowed down and turbulent is created. If the wind turbine is located in this zone of turbulence, the result will be very poor in the energy production and increase in the wear and tear of the blades, that is in the turbine. So what is the way to get rid of this solution, in the sense we have to keep away from this area, or we have to keep the turbine in the tall tower, not in the smaller tower. We have to keep, because we are using this tower station or the power station for 20 to 30 years. We have to consider the growth of the trees also for the lifetime of the growth of the trees. So we have to keep everything in the mind. And the distance, what is the area? Which area? It is a flat surface. It is near to the coastal area, then it is good. And it has to be, the wind power station has to be installed away from the buildings, nearly 200 meters or 250 meters away from the house, and 70 meters at a high distance. Then we are getting the very good wind energy for the generation of electricity. Sometimes whenever the wind is passing through the blade is like it is designed like an aerodynamical principle. Aerodynamical principle, in the sense the lower side it's like a very thin and upper side it is very strong. So it's like a fan structure. Whenever the wind is passing through this lower side, it will cause to rotate. It will cause to rotate the blade. The blade is made up of with either plastic material or it may be with a composite material. Second thing is nothing but we have to see the consideration and guidelines for the site selections. When looking for the place for a wind turbine, engineer considers the factors such as wind hazards or the characteristics of the land that affects the wind speed, the effect of one turbine on nearby turbines. We are keeping in the very nearby. You should not keep in the nearby. It should be distance in wind farms. So we have to consider those things. What are the factors, in the sense? Hill effect. Hill effect is nothing but, when you are talking about the hill effect, consider that when wind is starting from the one hill and it will reaches to the another hill, in between that the wind farm is there, in the sense then the compressed air will give the rises and gains the speed at approach the crest. So instead of keeping in the down, we can keep that in the wind farm in the upper of the hill or in the surface of the hill, in the sense then more air will be coming, then the speed is also increases. Roughness or the amount of friction in the earth surface exerts on the wind. The oceans have very little roughness or city or the forest has the great feel of roughness. So this roughness will slows the wind speed. Tunnel effect. While talking about the tunnel effect, increase in the air pressure undergoes when it encounters with the solid obstacles. That is between the two buildings or between the trees. That time what will happen in the sense the wind speed will be reduced. But the thing is, one more advantage in that one is nothing but surrounding air will be increases. It is enough to create the electricity, but even though it will not maintain in all the days, it is not a sustainable one. That we have to see that. Turbulence is nothing but rapid change in the speed and the direction of the wind, which is caused by the wind blowing over the natural or artificial barriers. We call it as a turbulence. Turbulence causes not only fluctuation in the speed of the wind, but also wear and tear of the turbine also. The turbine blades can sometimes it may be damaged or it may be failed to rotate. So the turbines are mounted on a tall towers to avoid the turbulence caused by the ground obstacles. Variation in the wind speed. During the day, the winds are usually blow faster than during the night. Because daytime the sun heats the air in the surface. But nighttime the sun is setting the air currents in motions. In addition, that wind speed can be differ in depending upon the season of the year. This difference is nothing but the function of sun, which heats the different air masses around the earth at different rates depending upon the tilt of the earth towards or away from the sun. Next is wake. Wake in the sense energy can be created or can neither be created or nor be destroyed. So wind passes over the blade of the turbine. The turbine stops much of the energy and converts into mechanical energy. The air coming out of the blade sweeps less energy when it is being that can be slowed. The energy that is falling onto the blade is very high. When it is passing over the blade is very slow. The abrupt change in the speed makes the wind turbulent. That phenomenon we call it as a wake. So because of this wake, the turbines in a wind farm are generally placed above about 3 rotor diameter away from one wind station to another wind. So it will not be in the same direction. Light will be tilted. One will be kept here, one will be kept here, but lightly tilted because do not absorb the air. Wind obstacles. The trees, buildings and rock formations are their main obstacles in the installation of wind turbines, which will reduce the wind speed and also increase the turbulence. So wind obstacles like a building which cause the wind shade, which reduce the wind speed and the output power also reduced. Wind shear, it is nothing but the difference of the wind speed in different heights. Level 1 the height, the speed will be different, and level 2 because 3 blades are there. So when the blade 1 is coming down and blade 2 is coming up, in the sense different levels of the wind will be approaching the wind blades. So when the wind turbine blade is pointed straight upward, the speed of the wind is hitting in the tip 9 miles per hour. But when the blade is pointing downward, 7 miles per hour is hitting. This difference places the stress on the blade. So too much wind shear can also cause the turbine to fail. This is also plays a very vital role. And choosing the right site for the wind turbine is the most important decision. We have to choose properly. The turbine work best when high and exposed sites, and coastal sites is especially good. Town centers and highly populated residential area is not suitable. Avoid roof mounted turbines because there is no guarantee of these devices that may damage the property through the vibration and also harmful to the birds. So farther distance between the turbine and the power requirement more power is lost through the cable itself. So that also be to be considered. The distance of the cabling has to be in the medium level. Turbulence disrupts the airflow that can wear down the blade and reduces the life cycle of the turbine. Small turbine requires an average wind speed of nearly 4.5 miles per second to produce the efficient level of the electricity. If the site is in a remote location, then connecting the wind turbine to the national grid will it's very expensive, because we have to use various electricity towers for carrying the power from generation to the distribution. And wind turbine power output variation with the steady wind speed. There are five important characteristics of the wind speeds. Startup speed is the speed at which the rotor and the blade assembly begin to rotate. Cut-in speed is nothing but the speed when the machine begins to produce the power. Design wind speed is the speed when the windmill reaches to the maximum efficiency. Rated wind speed is nothing but the speed when the machine reaches its maximum output power. Furling wind speed is nothing but the speed when the machine falls into the prevent the damage to the high wind speed. So cut-in speed, you have to think of it, the cut-in speed also. So cut-in speed is nothing but the minimum wind speed at which the wind turbine will generate the usable power. Rated speed is nothing but the power output from the wind turbine, which increases the wind. Cutout speed is nothing but very high speeds, that is around 25 miles per miles per second. Most wind turbine ceases the power generation and shut down if it is coming in the cutout speed. So wind speed at which the shutdown occurs is nothing but cutout speed or furling speed. Sometimes it is also called as furling speed. That time it will damage the speed sensor, it can damage the blades, it can damage the turbine. So it is not a safety wind. So braking system is happening during that time. Parts of the wind turbines are, it is nothing but nacelle, contains key components of wind turbine including gearbox and electrical generator. Tower of the wind turbine carries the nacelle and rotor. Rotor plates captures the wind energy and transfers the power to the rotor hub. The generator converts the mechanical energy of the rotating shaft to the electrical energy, and the gearbox increases the rotational speed of the shaft for the generator. And we have to consider the blade counts, how many blade will be involved for the particular process, that is determination of number of blades, which involves the design consideration of aerodynamic efficiency, component cost, system reliability, aesthetics. And also we have to see the noise emissions, because it is rotating, some noise will be produced that will be affected by the location of the blade, either by upwind or downwind of the tower. So noise emission from the blade, that also we have to consider, because it may be for 20 years or 50 years. Based upon that, we can use how many blades based upon the application. It may be used 2, or it may be 3, or it may be more than 3 also can be used. And one more thing is blade materials. The blade materials, normally wood or canvas sails are used early days. Now we are using the nearly plastic material or composite materials are used nowadays. In order to fibers are used for that. So important goal for the large blade system is to control the blade weight, since the blade mass scales the cube of the turbine radius. So loading due to the gravity constraints also we have to take care of that. So epoxy based composites also used for blade material in order to free from the environmental and production and cost advantages over the epoxy based system. Or we can go with the fabric system also. So we can use the resin type blade also. So using carbon fibers in 60 meters of turbine blades are used. So wind turbines may also benefit from the other kind of materials if you are using with the carbon material. Thank you.